This video is on the objective find an angle given two sides of a right triangle. Alright, so this is a video on specifically right triangles, right? So a triangle with a 90-degree angle or a pi over 2 radian angle in it. Let's take a look. So, as I say almost every video, if you are unfamiliar with the topic, want to see more about it, click on more instruction and look at their videos, their notes, their examples, and hopefully those help you out. So here we're given a right triangle. Alright, see this picture of a right triangle here. What we're asked to do is find the angle theta, right, labeled here. Find the angle theta in radians and round your answer to 4 decimal places, right? So the nearest 10,000th. Alright, so I've drawn a picture of this on a piece of paper. This triangle they gave us. And remember, for right triangles you can apply all the trigonometric ratios, and maybe hopefully you remember this this little acronym here, the SOHCAHTOA. Remember that the sine of an angle in a right triangle was the length of the opposite side divided by the length of the hypotenuse. The cosine of an angle in a right triangle was the length of the adjacent side divided by the length of the hypotenuse. And the tangent of an angle in a right triangle was the length of the opposite side divided by the length of the adjacent side. Now if we look at angle theta that we're asked to find here, and the side lengths that we know, let's see how those side lengths relate to angle theta. Well, this side here with a length of 10 units is the side opposite. I'll just put OPP for opposite. Alright, that's the side opposite angle theta. And then this side here with the other known length, length 5, this is the side. Now I know that there are two adjacent sides. Adjacent means touching or near. But this side here, right, the side opposite the 90-degree angle, is always the hypotenuse. Always called the hypotenuse. So yes, it is adjacent to the angle, but it's the hypotenuse. So this other side here is the adjacent side. I'll put ADJ for adjacent. So I'm trying to find angle theta, the measure of theta. I know the opposite length. I know the adjacent length. So since I know the opposite length and know the adjacent length, remember which of the trigonometric functions, which of the trigonometric ratios in a right triangle dealt with opposite and adjacent? That was tangent. So I'm going to set up this equation here. So the tangent of this angle theta is, the length opposite, 10, divided by the length adjacent, 5. Now 10 divided by 5 is 2. Right? So we have the tangent of this angle is 2. And then once you have an equation like this, you've solved trigonometric equations in previous assignments. A very quick way to get an angle, this is an acute angle here, right? Something between 0 and 90 degrees. A quick way to get an acute angle measure out of this is to use inverse tangent, right? So I'm going to be solving for theta here by simply taking the inverse tangent of both sides. And this just gives me one solution, but it's the only one I need. Right? I'm only looking for an angle, between 0 and 90 degrees, or between 0 and pi over 2 radians. And that's what the inverse tangent of 2 will give me. Alright, so I take the inverse tangent of 2. And this, will give me an angle between 0 and pi over 2. And we're asked to round it, so this angle, theta, measures the inverse, whatever the inverse tangent of 2 is. This is the correct answer. Alright. But, we're asked to round this to 4 decimal places, so I need to go to a calculator here. So they wanted things in radians, right? So I'm going to make sure I'm in radian mode here. Hit the mode button, yes I am. And then I'm taking the inverse tangent of 2. So this angle, right, this angle theta that we're asked to find measures approximately 1.1071, then it's 4 after the 4th decimal place, so 1.1071 when I round it to 4 decimal places. Now if you want to know how many degrees that is, remember just take your radians and multiply by 180 over pi, just to get see how many degrees is that. So this angle is approximately 63 degrees. Alright, it's about almost 63.5 degrees. But we're asked for radians, right? So back to here I'm going to enter 1.1071 rounded to 4 decimal places there. Wonderful. And again, look at their answer explanation. They're taking you through the same thing I just showed you, the inverse tangent of 2 eventually. And hopefully watching me do this, looking at the more instruction if you need to, reading the answer explanations when they come up. Hopefully all this stuff helps you out when you're working on this material on your own. And thank you very much for watching.